Hi everyone, I'm Francis. My PhD thesis is on computational imaging through optical chaos. What is chaos? We all know it is opposite of order. Well, it is the difference between walking after first can of beer and after 10th can of beer. Another way to look at chaos is that chaos lacks predictability. Say, for example, when you go from Estonia to Australia, we all know that we are supposed to drive on the opposite side, which means what was right will be on left and what was left will be on right. There is a change, but still it is predictable, so we feel safe. There are countries where vehicles come to you at all 360 degrees. This is chaos, and we fear chaos. In my PhD, I develop computational imaging techniques to predict the unpredictable. But what is chaos to an optical scientist? Imaging through scattering layers. But what is chaos to an optical scientist? Say, for example, this medium like fog or mist, they scatters light to speckle patterns like this, like the speckle patterns, which has almost zero resemblance to the object. So the goal of my PhD is to predict chaos in the form of fog or mist and to retain information of the occluded object. I am developing solution by attacking this problem on two fronts. Firstly, a modified assumption. I'm trying to develop solution, say for example, I try to see order in chaos by expressing chaos as summation of numerous orderly states, a concept called self-imaging. In other words, simply this chaotic medium like fog or mist are considered to be random collection of lenses, which means the information is present but differently presented. So I am developing computational algorithm to extract single image from this numerous self-images. Secondly, I develop or engineer optical beams that have special characteristics. They can pass through this fog or mist with high resilience, and they can retain information better than regular beams. By simultaneously applying these two concepts, I try to predict chaos. In my group, my colleagues used to call me magician, since I can see hidden objects. I believe that this technique will benefit areas like medical imaging, imaging through atmosphere, and especially winter car drivers of Estonia. Thank you for the opportunity.